Hello and welcome everyone. So glad you could join us on this very exciting night. I'm Paul Sutter. I'm an astrophysicist at OSU, and I'm also COSI's very own chief scientist. Tonight, I am your MC. My most important job comes later. I will be running the Q&A session after the talk. But for now, hey, how's it going? But for now, I'm going to introduce the guy who's going to introduce the speaker. Please welcome Dr. John Beacom, Director of OSU's Center for Cosmology and Astroparticle Physics.
Good evening and welcome to this special event. We're very excited about it. I hope you are too. So the Center for Cosmology and Astroparticle Physics has a sort of a three-part mission. We're researching the nature of the universe itself as well as all of the amazing things in it. And through our work with students, we're training the next generation of scientists. And then by sharing results with the public, we're working to help educate the next generation of scientists. And I'm happy to see a lot of people under 18 here today. Good job. Future scientists right there, yes? He's smiling. Yeah, okay, good. So a big part of our outreach is through the Biard Lecture Series, which was generously endowed by Captain Forrest R. Biard. And you can read more about him in the flyer that you got. And then, by the way, when you're on your way out, there's flyers you can pick up to find out about our many future events, and you can sign up to get announcements for them. I hope you do that. So tonight's speaker is the first astronaut to walk on Pluto, right? And return safely to Earth. Okay. So Dr. Alan Stern is a world-renowned scientist who has been the head of the New Horizons mission to Pluto. He didn't actually walk on it, did you? Okay, all right. He just hovered right above it. Okay. So he's been named Time's 100 most influential people. He's received more awards than there are people here tonight. And he's going to give us a special view of what they found in Pluto and nearby, some things that I think nobody else has ever seen. Please welcome Dr. Alan Stern.
Is that live? What do you know? See, I can't get a mission to Pluto. Gosh, it's great to be here. This is actually my first time visiting the OSU campus and COSI. What an amazing facility and staff COSI has here. You're very lucky to live in a place where there's something like COSI. And of course over at OSU, there's just an amazing physics and astronomy group, world class here in Columbus. And so I'm super honored to be invited to give this Biard lecture and to meet so many people and hopefully to meet some of you afterwards. And particularly to be in Ohio that has such strong roots in aviation. If it wasn't for the Wright brothers, you would not be sitting here listening to the story of a flight to Pluto, would you? But I am excited to be here, and I am excited to tell you about New Horizons. I have been fortunate in my career to be involved in 29 different spaceflight science mission teams and to be in a leadership role on 8 of them. And of all of those, New Horizons is my favorite, and I'm looking forward to telling you that story this evening. We had some interesting technical challenges getting going, so we'll see how this goes. What I'd like to do, I'm going to tell you the whole story of New Horizons, how we came to do it, what its objectives are and were, and some of the results. That's the eye candy bit, maybe the best part, and then I'll answer questions. But I'd like to start by putting the exploration of Pluto in some context of the exploration of our solar system. You live in a very special time in which we are opening up the solar system and turning little points of light into real worlds, into planets, by sending spacecraft to them. So I have a video that runs for about 2.5 minutes that I'll start here in just a moment. The National Space Society produced this video in 2015, and released it just before the flyby of Pluto, anticipating New Horizons. And it's the story of these 50 years of exploration. So, let's see if we can make this work. There it is.
It has been over 3,000 days since we left Earth. We're now almost 5 billion kilometers away from home. Out here, where the sun is distant and faint, is a place no one has ever seen before. Pluto and its system of moons, the farthest worlds ever to be explored by humankind. Since the beginning of history, the points of light in the sky have captivated us, particularly those special ones who mysteriously seem to wander. We call them planets. And upon learning that our planet is only one of many in our solar system, how could merely observing these points of light from home ever have been enough? Half a century ago, we began the exploration of all the planets, making ever more distant journeys. Each new world revealed its own startling complexity, character, and unimagined beauty. It has been a long wait since our visit to Neptune. But as we now approach the Pluto system, reaching farther again, our generation is about to complete the historic first era of planetary exploration. Who knows what wonders await us at these new horizons.
Well, that was how we imagined Pluto might look. Meet Pluto. How's that? This is the real deal. We sent a spacecraft all the way across our solar system. It took a decade. We flew 3 billion miles to explore this little planet on the frontier of our solar system. The people who worked on this project, in most cases, worked on it for 15 years in anonymity, sometimes nights and weekends. How many of you worked on a single project for 15 years to see if it would work on a single day, a single Tuesday, 15 years after you got started? This picture was taken on the morning of the flyby by a photographer friend of mine named Michael Soluri, who lives in Manhattan. At the moment that some of the members of our science team, you can see there, we're seeing the first close-up of Pluto arrive on Earth in real time. And you can see the energy in the room. You can feel how they were feeling. Look at the excitement after working on this from 2001 to 2015. That's such an amazing feeling for all of us. 2,500 men and women who worked on New Horizons to bring it to fruition. But the story doesn't begin in 2015. The story actually begins a long time ago, when Pluto was discovered by this guy. This man, Clyde Tombaugh, who was born in Illinois and grew up in Kansas, and who was hired by Lowell Observatory in Flagstaff, Arizona, to undertake a search that Percival Lowell, the founder of the observatory, began a quarter century before. in 1905. Tom Bell was hired and brought out there in 1929 to undertake the search single-handedly, to build the equipment, to develop the technique, to do all the data analysis, everything. And in the space of 9 months, he found their Planet X. He never once had a false alarm. Never once went to his boss and said, I found it. Never mind. The one and only time he knocked on his boss's door, Dr. Schleifer, I found your Planet X. He had. A few months later, the planet was named Pluto by an English schoolgirl named Venetia Burney, named after the god of the underworld because it's so far away that the light levels are very dim. And so the underworld part of mythology was adopted with this. Clyde Tombaugh lived into the 1990s and knew that we were building, or wanting to build at that time, a mission to go to fly to and explore his planet. I can say more about him in Q&A, but I'd like to tell you a little bit about why we do these things, and I'd like to start with this picture of Pluto. Don't laugh. Okay, laugh. This is the best picture of Pluto ever made before New Horizons. And it's okay to laugh. I took this picture with the Hubble Space Telescope myself. I was the principal investigator of that program in the 1990s. This is the best we could do. Even with the biggest, baddest gun in astronomy, the Hubble, the combination of Pluto's small size, which is only about the size of North America, and its great distance, 3 billion miles away, means that this is all you can see. Now, that didn't stop us as scientists. We wrote papers about this image, and ones just like it, and grossly overinterpreted those images. That's our job. But if you really want to study a planet, you need to have imagery more like this. With this kind of resolution, you can really tell what's going on a planet. And it's the reason that we send spacecraft to the planets, is to get that resolution so that we can really understand what's going on there. And to prove that point to you, I asked one of my postdocs, Amanda Zangari, to resample this image of the Earth, repixelate it, to the same resolution as that smudgy Hubble image of Pluto. What can you tell about the Earth at this resolution? You can't even tell there are continents and oceans. So that's the position that we were in studying Pluto from afar. And let me drive this point home one more time with a bit of a contest or a question. What are we looking at? Who wants to guess? Mars. It's a good guess, but it's flat wrong. At that resolution, you cannot tell what you are looking at. You have to go there. You know, the thing about going there is it's expensive because spaceflight is complicated. It takes large teams of people to put on a spaceflight. And as I said, in the case of New Horizons, over 2,500 Americans worked to build the rocket, the spacecraft, to be on the science team, and to do our mission control operations across the space of a decade. So you might ask, how do we raise the money? Now, I know what everybody's thinking. You probably started off something like this. We thought we could do it with commercial spaceflight. So we got some product placement ideas. We had some pretty good ones, in fact. We thought we might just get it started. Maybe we could raise $1 billion with advertising. Doesn't work that way. You have to do something else. In the sciences, you need a better reason. And let me tell you a story about this stamp. See what it says? Pluto not yet explored. In 1989, at the conclusion of the Voyager program that explored the giant planets of our solar system, all the planets out to Pluto had been explored by spacecraft. And the U.S. Postal Service, to commemorate that era of exploration, issued a set of 9 stamps, and each stamp had a picture of its planet and the first spacecraft mission to go there, until they got to Planet 9, and this was the only lame stamp that they could come up with. Pluto not yet explored. Now the thing is, if you go to NASA and say, let's go to Pluto because we haven't been there, you'll get laughed right out of the building. Because there are lots of places we haven't been and lots of uses for NASA's very limited budget. So what you really need is a strong scientific case, and not just a case you can make to the bureaucracy, but the way that NASA organizes priorities is through the National Academy of Sciences. And it's the National Academy that meets once every 10 years in a process called a decadal survey and takes all the good ideas and ranks them. Typically, in my field, in planetary science, there'll be about 100 proposals for mission concepts to asteroids and comets and landers on planets and rovers and orbiters and other kinds of missions. And really only a handful at the top, not just the A list, but the A+ list gets funded, because that's all the resources there are. So you have to get to the top of that list. And in the case of Pluto, we worked on this for a long time. We made that case and did design studies and refined how we did it. From 1989, the first study was published in 1990, you can see that long list, all the way to 2001, when New Horizons actually got funded. So it took a great deal of persistence by the scientific community to see this through. And time after time, we had to pick ourselves up off the ground and say, well, that didn't work out. Let's regroup. Let's think how we can sell this story better. Let's see how we make this go. Just like in business, we had to redouble our efforts. We had to apply persistence, sometimes fearless persistence. But we had a very good story. We knew from spectroscopy, the upper panel here in this diagram, that Pluto's surface composition, all those wiggles and dips, was unusually complex, that there were different kinds of snows, like molecular nitrogen and condensed methane, that's right, natural gas, and carbon monoxide, and other things on the surface that would make it compositionally very interesting. We knew, this is the lower left-hand panel, from a technique called stellar occultations, that Pluto has an atmosphere. In fact, we could tell pretty much for sure that it's made of the same stuff you're breathing, primarily made of nitrogen gas, just like the Earth's atmosphere is dominated by. We knew that Pluto had a giant moon, and that the pair had probably been created, as that bottom middle figure indicates, through a titanic collision, very much like the Earth-Moon system was formed. So we knew that by going to Pluto, we could find the only analog to the origin of the Earth-Moon system in the entire solar system. And this is my coolest surprise, because Pluto's way out there in the outer solar system and known to be covered in ices. We discovered from the orbit of Pluto and its moon what their masses were. And then by measuring their sizes and taking the ratios of mass to volume, we could get their densities. We discovered that although Pluto's big moon, called Charon, is primarily made of ice, the blue stuff in the diagram, that Pluto is primarily made of rock. Now, who ordered that? Who ordered a rocky planet on the icy edge of the solar system? Completely unexpected. And all these things and more that we knew back in the 90s drove interest in the scientific community and the National Academy of Sciences very high in sending a mission to Pluto, but never high enough to be at the very top and to get the funding. Let me tell you how we actually got it over the top. It was through a very important discovery. And I want to set some context for that discovery by showing you this diagram, which is a 20th century view of our planetary system, our home solar system. This is an old school view. It's all we knew, even as late as the tail end of the 20th century. Many of you probably saw something like this in a book in grade school. You know, you see squinched down by the sun in the middle, 4 little planets we call the terrestrial planets, Mercury, Venus, Earth, and Mars. All about the same size, like Earth, roughly, and all in close to the sun. They're surrounded by an asteroid belt, and then beyond them, 4 gargantuan gas giants, Jupiter, Saturn, Uranus, and Neptune, that are nothing like the 4 terrestrials, much farther out, completely different composition, and up to several hundred times more massive. And then beyond both sets, the terrestrials and the giant planets, was this crazy misfit called Pluto. It was in a wild orbit, and it was really tiny, and it's icy on the outside, but rocky on the inside, and it doesn't fit any part of the pattern, and it looked like a misfit. And that's probably what you learned about our solar system in grade school. It's certainly what I learned about our solar system in grade school. And it turns out it's completely wrong. And we didn't know it until the 90s. But beginning in the 1990s, because technology for both computers to analyze the data and CCD detectors, just like in your phone, but better, that could be used at the back end of telescopes, both came along to give us digital imaging and digital data processing. We started to find that Pluto's not out there alone. And We need to turn the sound down a little bit on this, but this is a video, sort of a cartoon that Alex Parker, who works for me, put together. And here you're looking down in the solar system, and you see the 4 circles, the concentric circles that orbits the giant planets. The big dot is Neptune rolling along its orbit. And all the dots that are appearing are Pluto's cohort being discovered across the 1990s. Hundreds, then thousands. It's estimated there are probably more than 100,000 objects 100 kilometers across or bigger in the Kuiper Belt. And some of them, as you can see from those fat dots that are appearing, are the sizes of small planets like Pluto. We discovered the solar system doesn't have 2 zones, terrestrial planets and giant planets, but 3 zones. The 3rd zone is called the Kuiper Belt. It's the largest structure in our planetary system. It's where Pluto orbits. And the lesson to all this is that Pluto wasn't a misfit at all. It was simply the brightest and the first discovered of a vast population that was unknown until the 1990s. It's as if up until the 90s we had maps of the Earth that were missing the Pacific Ocean, and we didn't know it. The 3rd zone of the solar system, the Kuiper Belt, is the true outer solar system. The region of the giant planets that we used to call the outer planets, this is now known to be the middle of the solar system. So when it was discovered that Pluto's not a misfit, but it was the harbinger of this 3rd zone and a whole new class of objects. In fact, most importantly, a whole new class of small planets. Look behind me, look at those. Those are all real objects shown to scale with Pluto. Some have moons, some do not. They have different colors, different surface compositions. Some have atmospheres, others do not. This is a heterogeneous population just like the terrestrial planets. In fact, there are more small planets, we call them dwarf planets, out in the Kuiper Belt than all the terrestrial planets and the giant planets combined. Now, who's the misfit now? When this realization came about, that there was a 3rd zone to the solar system populated by planets like Pluto, the scientific priority rocketed. Take a look at the next view graph. Shown across the top, the little girl's cute blowing planets for bubbles, but along the top, arranged from the largest planet all the way down to the smallest known planet in our solar system, look how many there are. Now, we'll leave aside whether astronomers can count to large, let's say astronomically large numbers, for another time, but look at that distribution of objects. Pluto's in there. Let me show you where Pluto is. That's Pluto. It's right in the middle. It's not the smallest. It's the largest of the little ones. And when the National Academy met in 2002 to rank missions, the discovery of the Kuiper Belt and this 3rd class of planets rocketed the priority for the exploration of Pluto to the very top of the A-list, the #1 priority, because by studying Pluto, we could not just find out about its fascinating surface and atmosphere and its giant moon, which was born like the Earth-Moon system, and all those other things about Pluto, but we could extend that knowledge to a whole new class of objects. So suddenly we were #1 on the runway. NASA conducted a competition. 5 teams formed. New Horizons was one of them. We competed for a year, writing big, thick proposals for how we would each do the mission. Keep it on cost, keep it on schedule, what the scientific capabilities would be, spacecraft capabilities, how we would build it, how we would test it, all those things, how we would fly it. Fortunately, at least from my chair, New Horizons won that competition in November of 2001 and got funded to build 1 spacecraft to fly all the way across the solar system to actually go to Pluto, the farthest worlds ever explored. Now, it's kind of funny. You win, you get what you asked for, and then you say, now what do we do? Because there was only 1 launch window for New Horizons to get to Pluto in time, and that was in January of 2006. Because that was the last chance to hitch a ride via Jupiter and get there in less than 10 years. Without Jupiter, it's a 14-year trip and much riskier, because your spacecraft will be much older. So we had 4 years and 2 months to do what previous missions had done. It typically took about 10 years, sometimes 12. Design, build, and test a very complex outer planet spacecraft. We had half the time. And get this, NASA told me you can have $800 million, which is a lot of money, until you realize that's 1/5 of what Voyager had. It's about 1/10 of the Cassini-Saturn orbiter. So we not only had to break the mold on schedule, we had to break the mold on how to do this inexpensively. And that's a whole nother presentation I could give on how we did both of those things. But I will tell you, the people that worked on New Horizons were the most dedicated people you will ever meet. You know, they accepted this challenge. We said we could do it. We won the proposal. We've got 4 years and 2 months. We've got to do it for 2 dimes on the dollar. Let's go make it happen. And they did. And I call that 4 years the blur. After we launched, I asked my secretary, Jeanette, count up how many plane tickets I took on New Horizons project during those 4 years. How many trips did I take? The answer, 232 trips. And I was typical. We were all over the country to subcontractors, to universities, back and forth to our main partner, the Johns Hopkins Applied Physics Lab, where the spacecraft was built. I was living on the road, and so was everybody else. 232 trips. That's 464 meals on United Airlines. If that's not service to your country, I don't know what it is. But everybody worked hard, and it was really an incredible period for all of us. Let me show you the spacecraft we built. This is it. This is New Horizons down at the Cape in Florida in November of 2005, right before we put it on the launch vehicle. And I liked showing this picture for a number of reasons. First, you can see how small the spacecraft is. There are people around it, so you can see the scale. It's about the size of a baby grand piano. And we built it to be small because that's how we made it go fast. That combination of a small spacecraft and a very large rocket resulted in a ferocious speed. Everything that's needed for the journey goes inside. Guidance systems, propulsion systems, the solid state memories, the thermal control, command and data handling computers, and everything's redundant. We have 2 of everything on board. You can see up on top that dish antenna, just like you might have on your house or you see on big buildings. That's for communicating with Earth by radio waves. Off pointing to the left is this big black thing that looks like a hair curler. It's not a hair curler. It's called an RTG, and it's actually a nuclear battery that provides all the power for New Horizons for the entire journey. Because we're going so far from the sun, we can't use solar rays. That generator is a technology that was pioneered in the 1960s and used for all the other outer planets missions. It's actually fueled by an element named plutonium, which is radioactive, and which was named for the planet Pluto. You know, there was a pattern back there, uranium for Uranus, neptunium for Neptune, and then plutonium for Pluto. I thought it was kind of cool we got to send plutonium to Pluto, and that's what powers our electricity. Outside of the spacecraft, on the spacecraft walls, are all of the apertures for the telescopes and spectrometers and other scientific instruments that are aboard. And this is an amazing high-tech machine. It packs incredible scientific firepower. The entire payload of 7 instruments on this spacecraft combined weighs less than just the camera on the Cassini-Saturn orbiter. And combined, all 7 instruments, if I turn them all on at once, they draw a whopping 28 watts. It's half a light bulb. And yet they have thousands of times the scientific firepower of the scientific instruments on Voyager that weighed a lot more, and that cost a lot more, and that drew a lot more power. So very much like 1970s computers filled a room and cost a fortune and weren't fast by today's standards, and now you've got a tablet that costs nothing with 1,000,000 times the power of an old mainframe. This spacecraft is light years ahead of Voyager and its predecessors, but cost a lot less, and weighed a lot less, and drew a lot less power. Really amazing machine. Now, before we launched it, we put some souvenirs on board, some mementos, and there are 9 of them. I don't have time to tell you about all 9, but I want to tell you about 2. The first one is, Clyde Tombaugh had asked at the end of his life that if a mission ever went to Pluto, would NASA kindly fly some of his ashes on the spacecraft? And I knew about that, and as the project leader, I was determined to make it happen. And his family sent those ashes to my office, and I carried them out to be put on the spacecraft. And you can see the words on there are the words on the plaque. You can read them for yourself, and there's a little disc with his ashes inside, and we flew Clyde's ashes on this mission. as a tribute to his accomplishment. He found the Kuiper Belt 60 years before anybody else. He found the dwarf planets 2 generations ahead of all the other smart guys in the 20th century. And we were very proud to do that. And one other thing I want to tell you is we took one of those stamps that said not yet explored, stuck it on the spacecraft. We thought we'd fly it right into Pluto's face. Take that. And then we put this spacecraft up on this enormous Atlas V rocket that we bought. This is the most powerful rocket in the US inventory. You can't tell by looking. It's as big as any building downtown here in Columbus. It's 225 feet tall. It produces over 2 million pounds of thrust. I'll show you its launch in a minute. We bought the most powerful version of it. I don't know about some of you. I used to be a kid who bought model rockets and mowed lawns and washed cars to earn money to buy bigger and bigger model rockets. You have no idea how much fun I had picking this baby out. With every upgrade, every way you could trick it out, with more solid rocket motors and a lightweight nose cone and, the special purpose third stage. It was just like heaven on earth to buy this monster the size of a downtown building, and it's mine. And anyway, so New Horizons was basically a little hood ornament up on top of this thing. Right? We more or less launched an Atlas V. It's built to launch satellites the size of Greyhound buses. We launched it with this little thing in the payload bay so that at the end result is this enormous speed that we could achieve. That's New Horizons inside the nose cone, inside that hatch. And this is my favorite picture of New Horizons itself, and I want to tell that story very briefly. This is the day that we fueled the nuclear reactor, the nuclear battery, with its plutonium. And as soon as we did that, it was radioactively hot, so they needed to close the hatch, which is a radiation shield, and get us on our way. But we had arranged to have quick pictures taken by the project leaders, and I asked if I could go last as the mission principal investigator, and I did that for a reason. I'd worked on this thing since 1989, it was 2006, and I knew that my picture with New Horizons would be the last picture ever taken of New Horizons, because then the hatch was put on, the door was shut, nobody ever saw it again. That's why I love this picture. There's one footnote to it. Let me tell you what day this is, because it's our lucky day. It's the day we powered up our spacecraft. It became alive, and it has been ever since. That picture was taken on Friday the 13th of January 2006. And then 6 days later, we lit the fuse, and I'm going to show you a video of the launch now. And I want you to, if you haven't been to the launch of a big rocket, it's hard to appreciate how enormous this rocket is. But watch it get up and launch off the pad when it's empty. It just leaps off the pad at 2 G's acceleration. You'll see it pass through a cloud deck in about 10 seconds up at 10,000 feet. It goes supersonic, a downtown building going supersonic in 28 seconds. So we need to start this little video, and it does have sound.
Status check.
Go Atlas.
Go Centaur.
This is Atlas Launch Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system.
Shortly you'll see the solid rocket motors burn out and detach. And if you watch closely, they come to our part in 2 waves, so they don't collide with each other. And now the main stage can accelerate the spacecraft even faster. When we get up high enough, we can drop off the nose cone because we don't have any wind resistance any longer. And there you can see that. Those panels are about 70 feet tall. 6 minutes later, we were in Earth orbit, 18,000 miles per hour. We flew around the Earth about halfway to where we had calculated we needed to fire the engines to go straight off to Jupiter. We did that. Second stage fired, took us out of Earth orbit. Third stage fired, and took us to very high acceleration, 14 Gs. And when we got off that third stage, New Horizons was the fastest spacecraft ever launched. We set a speed record, which is absolutely amazing. When I was a kid and Apollo missions were flying to the moon, the burnout speed was 25,000 miles an hour, and it took 3 days to reach the moon. And New Horizons reached the moon in 9 hours. And then we were off across the solar system on a 9.5-year journey, traveling about 1 million kilometers per day, every day, 7 days a week, 365 days a year. We reached Jupiter for gravity assist 13 months after launch. For comparison, the previous mission to Jupiter had taken 4.5 years. The one before that was 6.5 years, so we did that in 1.1 years. We used Jupiter as a flight test and a gravity assist, so we practiced all the techniques for a Pluto flyby there. It's the only thing we passed along the way. We did a lot of good science. These are images of Jupiter and its volcanic moon Io made by New Horizons. We actually conducted about 700 different scientific observations at Jupiter, and you can see from the magazine cover that we made the cover of the Rolling Stone for geeks. And then we had an 8-year journey from Jupiter out to Pluto. So I'm just going to fast forward. I could tell you what we were doing along the way if you have questions, but I'm going to fast forward to the Pluto flyby that took place in 2015. And this is the gentleman that you see there with the flag is Glenn Fountain, who is the New Horizons project manager until last year. Glenn retired last year after being 50 years in aerospace. This was his culminating project. And then you see in the upper right our little control room in Maryland at the Johns Hopkins Applied Physics Lab, where we operate New Horizons from, and one of our flight controllers there. This is kind of a timeline of the flyby. It began in January of 2015, just over 2 years ago, and continued for 6 months as we approached Pluto, getting better and better imagery every week, week after week. We surpassed Hubble resolution, that blurry Hubble resolution, in April. And did the close flyby in July. And then one of the secrets of New Horizons was that we built it to take data like a fire hose. So we had enormous solid state memories on board, and we took this is not a made up number, 5,000 times as much data as the first mission to Mars, and stored it on flash drives. But to get it all back to the Earth took 16 months. So the data kept coming back. It kept raining presents, images and spectra from the Kuiper Belt every week for the rest of 2015 and almost all of 2016, finishing in October, just 3 months ago, when all the data was back on the Earth. Now, the flyby involved studying not just Pluto and its big moon Charon, but all 6 objects that are known in the system, because Pluto also has 4 small moons. So we had to choreograph scientific observations by 7 instruments studying 6 different bodies as we flew by at 20 times the speed of a Mach 2 fighter. And in order to get some of the science right, we had to fly through the shadows of Pluto and its big moon Charon, because we wanted to watch the sun set through Pluto's atmosphere as a composition experiment, using the sun's light as a beam. And in order to do that, we had to hit a window in space, a rectangular window that's 60 by 100 kilometers, which sounds enormous. I'm sure it's bigger than this county here where you live. But aiming from 3 billion miles away, it's not a very big target. And somebody did the math for me and said that it's equivalent of hitting a golf ball in Los Angeles and doing a hole-in-one in Manhattan. And we did that. Also, we did that. Well, that's American ingenuity. But in addition, the spacecraft's not so smart in some ways. In some ways, it's got lots of intelligence on board, particularly for handling real-time failures. But it actually just is a point-and-shoot device. So we calculate for any given target where it's going to be in the sky, and it better be there, because that's where we're going to point it to where we expect it. But the spacecraft doesn't have eyes and ears that can actually see it and lock on. So when you build a bargain basement cost mission, you got to make some compromises. So in order to make all that work, we had to arrive on a schedule that was set in 2006 to within plus or minus 9 minutes. And we did. We actually arrived only 86 seconds off target after 9.5 years. Now, I will tell you, I came to Columbus last night on United Airlines, and they couldn't even get that good, and it was only a 2-hour flight. But by the way, I'm very proud of the fact that when we arrived 86 seconds off target, we were early. That was good. Okay, so let's talk a little bit about what we found. Here's a family portrait of the Pluto system. This is Pluto, obviously the big guy in the lower right. It's big moon Charon, up into the left of it. Charon's about the size of the state of Texas. Pluto would just about blot out the United States on a map of North America. And then two of the smaller moons called Nix and Hydra in the upper left. And then there are two more moons that are too small to be seen in this image. But here are all 4 of the small moons as seen by New Horizons. Styx, Nix, Kerberos, and Hydra in their order of distance from Pluto. That's what they're shaped like. They're very bright and reflective, like brand new fresh snow. 80% reflective. We don't know how the ice remains so clean. We have compositional spectra. They're all made of water ice. The biggest 2 are about the size of this county. The 2 smaller ones are like the size of a little township, just 10 kilometers, 5 miles across. And I'm not going to spend a lot of time on them, but I do want to tell you they're all tumbling very fast in their orbits, much faster than scientific prediction, which would have them rotating synchronously, so that they spin once per orbit. But they're all actually excited by some sort of energy input from the Pluto-Charon binary, which we don't completely understand. We got great data on Pluto's big moon. This is Charon. This is the one that was discovered in the 1970s and which was the result of that giant impact. Everything you see there is made of water ice. It's just all water ice, frozen. It's 400 degrees below zero out there. And you can see it's pretty battered by impacts. You can see it as a giant canyon system across its equator. That canyon is 10 times longer and 10 times deeper than the Grand Canyon. Charon is about the diameter of the state of Texas. So for how many of you have driven across Texas? From, say, from El Paso all the way across to Beaumont. How many of you? It's awful, isn't it? So this is a pretty big place. You can see lots of evidence of geologic activity, but we can also date the surface by counting the number of craters. And you know, if you take a piece of paper out in the rain, the more dots on it, the longer it's been out in the rain. It's raining meteors that make those craters, and so that's how we do the age dating, by calculating the cratering rates and then counting the number of craters, and the ratio gives us, it's a little fancier than that, but gives us the age. And everything you're seeing is a world that died 4 billion years ago, shortly after its formation. It's cooled off. In fact, inside, where the water ice cooled, it expanded, and that's what caused this enormous extensional tectonic belt. This big crack is due to the water ice expanding and cracking all the way across the whole world. Up at the North Pole, there's that giant red stain, which we're pretty sure is due to gases that came from Pluto's atmosphere, ran into Charon, and where it's coldest at the pole, they could condense out. And then over time, solar radiation reddens them and darkens them to just that color. In fact, we can simulate that in vacuum chambers in laboratories on Earth, and we get exactly this. So we're pretty sure we're right about that. Now let me show you Pluto and Charon together. That's the binary. This is the first binary planet we've ever been to. You can see Pluto looks much more colorful and much more reflective than Charon. It's interesting because they've lived together for 4 billion years, but they don't look a thing alike. I mean, they've been in the same temperature environment, the same radiation bath, the same cratering environment, and they look completely different. And just imagine when we go exploring all those other planets of the Kuiper Belt, how much variety we might find if two that live together all that time can look this different. But let's see Pluto in more detail. So that's the view you would get if you were an astronaut 1,000 miles above Pluto, looking down on the globe of Pluto. Pretty amazing place. That big, giant, white teardrop feature is something we have informally named Sputnik Planum. It's a giant nitrogen glacier. It's 1 million square kilometers in size, so it's the size of Oklahoma and Texas combined. And it's surrounded, you can see it's surrounded by mountain ranges which soar 10 to 15,000 feet above the plane. I'm going to show you a lot more about Pluto. These are close-ups, and in every image, if you look at that little color image in the upper right, you'll see the disk of Pluto's approach hemisphere, what we flew over, and the little green box shows you where on the planet we're looking. And in every one of the next 6 or 8 slides, as I show you some interesting things on Pluto, you'll see that context image. So here we're looking where that green box is, up on the shoreline between the glacier and the surrounding mountains. And what we discovered here is, first, you can't find any craters on this glacier, which means it's very young. We can age date it, and I'll say more about that in a few minutes. But we also see that where the glacier abuts the mountains, there are strong flow patterns. The glacier is moving, just like if you've been to Iceland or to glaciers in Alaska or, say, northern Canada. These glaciers at 400 degrees below zero are moving. Pluto is geologically alive. In fact, here's more evidence of geologic activity. This is a topographic map made from stereo images that New Horizons obtained. The greenish and yellowish areas, the blue, are high regions up in the mountains. And then the lowlands are these big plains down on the glacier. And here, through this chasm, we see this huge pool of snow that came out probably as an avalanche in the recent past because there are no craters on it, and that would have flooded all of Columbus and its entire surroundings. It's a vast area caused by avalanches on Pluto, 3 billion miles from the sun, out in the Kuiper Belt. Who knew? We see areas that are very heavily cratered and old on the surface of Pluto, where the craters are so shoulder to shoulder that if you had any new craters come, they just obliterate and cover up old craters. You can't fit any more in. Here's a close-up on the nitrogen glacier, Sputnik. And one thing you see here, as I said, no craters whatsoever. Not one. We've looked as carefully as you can look across the entirety of 1 million square kilometers, and we can't find one crater, which means that this glacier must be renewing itself thousands of times over the age of the solar system. It must be less than 10 million years old. It might only be 1,000 years old. We don't know. But somehow Pluto is creating vast new terrains after all this time. And we didn't think small planets could be so geologically active. But, well, that's what the textbook said. Throw the textbook out. We were wrong. Also, if you notice that cellular pattern in the ice, that's not biological cells. Those are geological cells. And they're caused by heat coming from below and causing the ice to convect. And nowhere across the entirety of the solar system have we ever seen a convecting glacier like this. We see things like this on the Earth. What the heat source is below this that's causing it is something, could be like out of a sci-fi novel. Nobody really knows. People have ideas, but nothing like this has ever been seen before. When we age date different surface units on Pluto, and pardon me for geeking out with a log graph here, but this is to say that we find terrains that are as old as the solar system, 4 billion years old, terrains like Sputnik that are brand new, and terrains that are middle-aged. And that means that Sputnik's not an anomaly. It didn't just happen and Pluto had been dead for billions of years, something changed. Pluto's been active the whole time. And how you power a small planet that can easily cool off over billions of years is a huge technical challenge to geophysicists that we didn't even know existed before New Horizons. But New Horizons is the first example of an Energizer Bunny small planet. I just like showing this picture because I live in Colorado and we have the Rockies with snow caps. And to find snow caps on the mountains of Pluto, I think is just stunningly beautiful. This area that you're seeing is about the size of western Colorado. And those mountains are about 10,000 feet high. But the snow caps you see on them aren't made of water ice like in the Rockies where I live. That's methane. It's condensed natural gas, which if you do that in a laboratory is bright white, just like water ice snow. But it's completely different. It's a fuel, right? Fortunately, there's no oxygen in Pluto's atmosphere because if there was a single spark, the whole place would go up. But there's no oxygen, so it can't burn. Here's another example of completely wild terrain, which we call snakeskin. We don't know what to really call it. These are bladed mountain ranges that run for hundreds of miles across Pluto, made of methane ice They soar 1,000 feet in the sky, typically 300 meters tall. We don't know what causes them. We don't know if they're giant crystals like in a science fiction novel that are growing, or if they're regions where the valleys have been eroded by winds that have carried softer material away. We have no idea. We have never seen anything like this anywhere else. And if you get the idea, I keep telling you, we've never seen anything like this, we've never seen anything like this. One of the things about Pluto is just, we could rename the planet SOPHY, which is an acronym, something for everyone, because everywhere you look, there's this geological diversity. I mean, look at this. There are volcanoes the size of Mauna Loa on the surface of Pluto. Big volcanic calderas, and they're young too. They don't have craters on them. How does Pluto do this? Look at this. Who ordered a frozen lake bed? It's 20 miles long. You can't even have liquids on Pluto's surface today. It's too cold, and the atmospheric pressure is too low. You can't get to the triple point. This is direct evidence. If we were on CSI, we would clinch the case that right here, from this evidence, that Pluto used to have a thicker atmosphere. Maybe as thick as Mars, maybe even thicker. Because in order to have that frozen lake, it had to be a lake. In order to be a lake, it had to be warmer and higher pressure. Period. Done. See the shoreline? We think Pluto goes through atmospheric cycles, where it has a much thicker atmosphere and a much thinner atmosphere. None of this was known before July of 2015. I love this picture. It's looking back 15 minutes after the flyby, and you can see the rugged terrains on Pluto's surface, and you feel like you're almost there. But the coolest thing is, you can see that atmosphere that we discovered from the Earth, stretching up 500,000 feet into the sky. These concentric haze layers are obvious to the most casual inspection. This is right on the region where day is turning to night. We call it the terminator. You can see the shadows of mountains. If they can lower the lights, this would be better, stretching out. You see those shadows? It's really hard unless they lower the lights. But there are ground fogs and hazes down in the valleys, just like you would find somewhere humid on the Earth with mountains. It's stunning. There's one other thing in this picture, but you have to promise not to tweet it. We found Mount Rushmore on Pluto right there. All right, I'm getting to the end. So what I want to do, the last thing I want to show you on Pluto is a little short video made from high-resolution New Horizons images. These images have high enough resolution to pick out individual buildings in Columbus, if we flew over Columbus at the same altitude. And it's our highest resolution strip. We're going to fly right down on the deck as if you were in an airplane flying over Pluto. I might have to start this video. There we go. So we're going to fly right down onto Pluto's North Pole. See the box? We're going to start at the limb up there. And then, in the space of 60 seconds, you're going to fly across 1,000 miles. As we go across the heavily mantled polar terrains, you can look inside of Pluto. These craters are windows into the interior. We see what appear to be dust devil tracks or tornado tracks over the surface. Then we go up onto Badlands and into big, giant mountain blocks that are 10 and 20 miles across and 10,000 feet high. And then off across the shoreline onto Sputnik Glacier, where you see that cellular pattern of convection. You see islands of water ice sticking up through the nitrogen. Just an amazing place. It's amazing the technology that we have in this country to do these kinds of things. Let me reflect back for just a minute, because I'm going to finish right here. Let me start by saying that stamp that we flew to Pluto, when we got there, we canceled it. See the two words that are crossed out? Now it says Pluto explored. And the interesting thing about that is this image got picked up on all kinds of social media in July of 2015. And it so galled the Postal Service that they've since issued new stamps that correct everything. And you can go to the post office here in Columbus and buy yourself these stamps. They're forever stamps, so you buy them for today's prices. And you can use them as souvenirs or just to send to your friends, and you can use them forever. So yeah, you should get some. I want to show you a couple of newspaper covers. For 15 years, while my team was working in anonymity night and day, I promised them that in the middle of July, the fantastic futuristic year of 2015, that what they were doing would make the front page of the New York Times and would be above the fold. And there, on the left, you see it, above the fold, the morning after the flyby, there's imagery from Pluto on the New York Times. And we were on the cover of 458 newspapers, front page the next day, on every continent of the Earth, including Antarctica. And I know that because the only paper in Antarctica sent me a PDF of their cover. It's true. And if you read the fine print, I know it's not in very good focus, but that says, late edition, July the 16th, 2015. On the other side of the page is the first pictures returned from Mars, also by an American spacecraft. And if you read the New York Times details up here, it says late edition, same date, July the 16th, but 1965. 50 years before to the very day. In the space of those 50 years, in the space of the lifetimes of some people in this room, your country explored the entire solar system. We were first to every single planet, and we'll go down in history for that. Thank you for your support. To put this in perspective, if you're wondering how much you spent on New Horizons as an individual taxpayer, I will tell you that if you bought the Time magazine about New Horizons in 2015, you spent more on that purchase than all of your tax dollars that went to New Horizons. This country is stuck with this, and it is tremendous. We make the data available from all of these missions to everyone all over the world. Kids in every country on the Earth that learn about the planets read about the American brand. They read words like NASA and Voyager and New Horizons and Mariner. That's called soft power projection. And kids will read about this in the 22nd century, in the 23rd, and the 24th. This is the one pair of generations from the 60s to our time that swept across the solar system, turned all those points of light into planets, into real places that your children and grandchildren will hopefully have a chance to help explore and then settle. And I know that sounds fantastic, but imagine how it felt in 1493 to think about North America one day having cities with millions of people, and that the transport to get across that ocean wouldn't take months, but hours. They would have just not believed you could do it. Hundreds of years from now, when Star Trek actually happens, people will look back. This is the time that we opened up the solar system. And the New Horizons team could not be prouder than to have run the anchor leg in that 9-planet relay and wrap it up 50 years to the day after we started it. I'm going to end with my favorite picture of Pluto. This is true color. Pluto's atmosphere is actually blue, just like the skies of the Earth. This picture is a picture of Pluto backlit by the sun. And for those of you who remember seeing the images that Apollo astronauts took of Earthrise over the limb of the moon, you might not know this, particularly if you're younger, but they were very powerful images emotionally because no one had ever seen anything like that. It proved those astronauts were really there. It was a view you could only have, the Earth rising over the limb of the moon, by being there. Well, guess what? You can only get this picture from the far side of Pluto. And after I worked on this for 26 years, from 1989 to 1915, I picked this out as my favorite picture because you can only get this one from the far side of Pluto. We did it. Thank you very much. Oh, I have one more thing. Okay, so I think we have time for questions, and I like to think that New Horizons has the coolest bumper sticker in the space business. It says, "My other vehicle explored Pluto." Then there's Pluto in the rearview mirror, and then it says, in fine print, "Objects in the mirror were closer than they appear." So we have about a half dozen of these for the first people who ask questions, as an incentive to get your hand up in the air.
Okay. Right before we start the questions, I just want to do one last thing. That was wonderful. I think everybody agrees. The spirit of exploration there was really great. Now, I mentioned that this Biard Lecture Series was endowed by the Biard family, and we're very grateful to their generous support. We've been running this for about 10 years now. We have a representative from the Biard family here tonight. Sherry Poston, can you wave at us? Where's Sherry? There we are. And it's really important how many people, especially young people, first find out about their interest in science through something like this. Now, when we started this series about a decade ago, it took incredible foresight to plan this lecture, the 9th lecture on the 9th object in this planet. Okay, thank God, the 9th planet.
Get over it.
And so we'd like to thank Dr. Alan Stern for this. Thanks very much. Now, to learn more about the research that we're doing here, you can pick up from some of these pamphlets on the way out, and to learn more about our outreach missions and our other public talks, also pamphlets on the way out. And I want to reintroduce my colleague at OSU, Dr. Paul Sutter, and also COSI Chief Scientist. And he's a great example of the way we're bringing the research at OSU to the outreach at COSI. So let's turn it over to Paul.
Thank you. All right, Dr. Stern, I would like to ask you 6 questions before I take from the audience. Is that all right? Is that all right? No, that's not all right at all. Who has a question for Dr. Stern? Everybody has a question. I'm going to start easy right here so I don't have to run far. What's your question?
So you mentioned several times that you and everyone else on the New Horizons team, you had to remain anonymous. I was just wondering why that was.
Well, it's just you're working behind the scenes. And how much did you know about New Horizons until we did the flyby? Maybe some of you heard about us around the time we launched. But for the most part, you're just working towards a goal. And you don't do it for fame. You do it to make a contribution. And so you work hard, and just like in most businesses, you're just doing your job.
Very good. Another question right here.
How does the dual movement between Pluto and Charon affect Pluto's other moons, and how does that work?
How does the what?
How does the binary movement between Pluto and Charon affect the orbits of Pluto's other moons?
Okay, great question. So the binary has interacted gravitationally. So the tidal forces between the two have slowed Charon down so that its spin period is the same as its orbit period. And so just like our moon, where you see the face on the moon is always facing us, one side of Charon always faces Pluto, and it actually hangs over one place on Pluto. And so they rotate as if they are glued together with a stick between them, like a rigid body. And then the other 4 orbit further out. And as they orbit, every 6.4 days, as Pluto and Charon rotate, that lump on the side of Pluto, the size of Texas, called Charon, goes by and creates a gravitational impulse that's strongest on the innermost moon, Styx, and weakest on the farthest, Hydra, but affects each of them and interacts with their orbits to cause them to tumble. Exactly how all that works out mathematically depends upon a lot of details, but that's the basics.
Excellent question. We have one right here.
When did people start exploring space?
Well, the question is, when did people start exploring space? And the first spacecraft that just went up and touched space were in the 1940s. The first ones to go into orbit were in the 1950s. The first people to go into space were in the 1960s. And then ever since, more and more.
Nice. So there's a question right in the middle. I need you to do a favor and pass the microphone down. Then the last question, then pass it back, because I really like my microphone, okay?
Do you know where New Horizons is right now?
I do. I bet that wasn't the question. Why don't I tell you, I'm going to guess your second question. So New Horizons is traveling so fast that it's escaping the solar system and flying out into the galaxy. And we are now about 500 million miles past Pluto. That was fast. And traveling to another flyby, which the spacecraft will conduct at the end of next year Actually, the closest approach is on January 1st, 2019. But we are going to have one hell of a New Year's Eve party on the New Horizons project, and it will broadcast it, and you'll be able to join in.
Excellent question. I'm all the way here in the back. Here we go.
Yeah.
What would be the best explanation?
What will be the best next exploration for space from your perspective?
What would be the best exploration for space? The next or the best? The next?
The next best.
Oh, both.
I mean, ignore the next boring ones. The next best one.
You know, so I'm not quite sure what you mean, so I'm going to answer it two different ways. So the next best mission that I think you're going to see is going to be a mission to this ocean moon of Jupiter called Europa to find out all the details about its ocean and what it's made of, whether there might be life in it, things like that. But the next best mission I'd like to see us do is to send people to Mars. I think it would be inspiring.
You can clap to that. You can clap to that. Next question. I'm out of bumper stickers, but that doesn't mean you have to stop asking questions. We've got a grown-up here. Make it a cute question.
Speaking of Europa, that's kind of leading into mine. Are we alone?
Are we alone? That's a really good question no one knows the answer to.
What say you?
What say I? I'm betting on we're not. In spades.
We're probably not alone. Okay, another question.
I know why Pluto was demoted to a dwarf planet, but I want to hear your side on it.
Excellent. You're in the hot seat. Pluto, planet, dwarf planet, what's the deal?
You guys don't actually believe that dwarf planet stuff.
Oh.
Yeah. So first of all, let me tell you my favorite test for planets. How many people watch Star Trek? Raise your hand. Everybody watches Star Trek. Okay. So what happens at the beginning of a Star Trek episode is they show up somewhere. You're on the bridge. They turn on the viewfinder, and you see something where they are, right? And what happens? In about a second, you know what they're orbiting, right? You can tell that's an asteroid, that's a planet, that's a star, that's a Klingon spacecraft. You can tell right away, right? You don't have to do a bunch of calculations and go see what's where in the solar system and what cleared its orbit and all that. You know a planet when you see one, right? I call it the Star Trek test. Now, if Pluto appeared on the viewfinder, what would you call it? There you go. Okay, so I just like to know what the audience thinks. So let me show you something called the Pluto salute. You put 9 fingers right up like this. Now, you can do this. If you think Pluto's a planet, do the Pluto salute right now. Now, somebody should take a picture of this because it's
We've got pictures.
the audience.
Oh, yeah, this is great.
Okay, we're done. Answer to your question.
The science is settled in this auditorium.
Yeah, so you know that IAU, Irrelevant Astronomical Union thing?
Oh,
yeah.
laying it down.
Yeah,
I do have a question for you. You mentioned Europa and the water underneath the ice of Europa. I heard that there is some evidence for liquid water underneath the crust of Pluto. How solid is that evidence?
How solid is the liquid evidence?
Yes, exactly.
Well, we have geophysical models that predict the temperature and pressure conditions inside of Pluto as a function of depth. And we know that the crust is made of water ice. And so we predict from those models that there's an ocean tens to hundreds of kilometers deep below the ice, of water ice. The best evidence that we have for it comes in 2 forms. One, we measure the shape of Pluto with New Horizons, and it's a perfectly spherical ball with no bulge on it, meaning that there's something soft inside, like water. Secondly, that big heart-shaped region where Sputnik is just happens to lie precisely opposite where Charon is, and that's a very unlikely event unless there's a mass concentration right where Sputnik is. What kind of mass concentration could there be? Well, it turns out water ice and water are denser than the nitrogen. So that's, again, circumstantial evidence. It's pointing towards the validity of the ocean theory. Now, neither of those clinch the case. To clinch the case, we probably need to go back with an orbiter that can do gravity mapping, have a ground penetrating radar, look for geysers, things like that. And anybody in this audience that wants to be principal investigator on that mission, I'll help you.
Very nice.
We have a volunteer right here, that young
right
guy.
there you are. All right. And you asked a question. That's what principal investigators do.
There you go.
They ask questions. We've got another one right here.
How long do the photos take from New Horizons, that was at Pluto, to come to Earth?
Good, great question. So the photos come by radio, and the radio signals travel at the speed of light. That's 186,282 miles per second. And traveling at that speed from Pluto all the way back to the Earth takes 4.5 hours. So when we send a picture, it takes about an hour to send a single picture through our telecommunications system. And so for about an hour it's transmitting, and then you can think of this wave train of bits traveling coherently across the solar system back to the Earth, where there are giant antennas that receive them for about an hour and then construct a picture out of it. And then we do that over and over, thousands of images and spectra and so forth. And that's how we build up the maps.
Excellent. We've got a question right here.
So how exactly did you persist and keep trying to get funding for 15 years?
Yeah. You have to really want it. You do, but I'll tell you, you know, in what I call my parents' generation of planetary scientists, even though my parents weren't planetary scientists, in the generation of the 60s and 70s and 80s, they got to have all the fun. They got to do the first missions to the first 8. And then by the time my generation came on the scene, it's kind of Pluto was the last train to Clarksville. Last chance. And so in terms of making a scientific contribution to the exploration of our solar system, this was a place where everybody on the project felt like we're doing something really important. We're completing the reconnaissance of the solar system, first mission to the third zone, first mission to the dwarf planets. Everybody wants to know what Pluto looks like. And so it was pretty easy, actually. Not every day. We had some bad weeks and some bad days, but big picture, we were convinced that this was a really important thing to do and to spend our careers on. And so we just stuck with it. And almost no one quit. It's what was the most amazing to me is in all those years, very few people just put their pencil down. As a team, everybody stuck with it. It's an amazing story.
That is amazing. Here's another question.
Okay, so I have 2 questions. The first one is how much longer...
One bumper sticker. She can have the last bumper sticker.
Thank you. So how much longer do you expect New Horizons to be transmitting data? Can you give me like a ballpark estimate of like how long?
Yeah. So if nothing breaks, and so far nothing's broken, and we have all these backup systems we don't even use, we have enough fuel and power to run the spacecraft for 20 years, maybe a little longer. So out into the 30s.
Okay, cool. And then my second question is, what do you think of Pluto's future in terms of atmospheric escape? Since it's drastically changed the atmosphere and its contents over the billions of years.
Right, so she asks a question that requires me doing a little explaining. So Pluto's low gravity allows its atmosphere to escape, but it escapes much more slowly than we thought before the flyby, because the atmosphere is colder than we thought before the flyby. So Pluto's atmosphere is currently not escaping very fast. And the evidence that I showed you for things like lakes in the past indicate that the atmosphere used to be bulkier and probably had higher escape rates then. The best models we have that are still pretty primitive, mathematical models, show that Pluto's atmosphere rises in pressure by factors of thousands compared to today, and then plummets back to the current state over and over and over, every few million years. So Pluto probably goes through these huge transformations, just like the Earth goes in and out of ice ages, but on a more gargantuan scale. And during those heavy atmospheric periods, the escape rate probably goes up. That's probably when the feature on Sharon's North Pole gets renewed. through atmospheric escape. But we really have a lot more work to do to really pin this down as a scientific theory.
All right, how's it going, guys? I heard there's a question over here. All right.
Thank you, Dr. Stern. I'm a huge fan of Pluto, New Horizons, and of you. And the reason why I say that is not only because it's true, but also because I have two questions which I hope you would answer. My first question is about tholins, which are the red organic gunk that we see on Pluto, and also a little bit on Charon, and also the object that it's heading towards in 2019. My question is, why do we not see tholins in the inner solar system, the asteroid belt, or perhaps some of the Jovian moons, for example? My second question is, does Pluto have Voyager-esque equipment on board to study the heliopause or the interstellar medium, for example?
Yeah. So your first question about tholins is why don't we see them in the inner solar system? And it's because the tholins that you see there are created by the interaction of cosmic rays and ultraviolet light with the ices on Pluto's surface, and those ices don't exist in the inner solar system. And in your list of places we didn't see tholins, you include the moons of Jupiter. Actually, we do find those tholins on the surfaces of the icy Galilean satellites, and you can read more about that. Your other question was whether we carry instrumentation like the Voyagers do to study the outer heliosphere. Yes, and we're already doing that. We're collaborating with Voyager. They're much farther out than we are because they launched literally 30 years before we did. However, the instrumentation that we have is so much more advanced that it's about 1,000 times as sensitive as the stuff on Voyager. And so we can see much smaller scale structures, much shorter time scale fluctuations, and we will continue to go out into the heliosphere, and we hopefully, the question about how long we would go, and by the time we get to the 2030s, hopefully we'll make it into interstellar space.
All right, unfortunately, we're almost out of time, so these are going to be the last couple questions. I've seen these hands up the whole time I've been running around, so you get to go first.
My question is, how many planets do we really know about?
That's a great question. So if you count planets like planetary scientists do, which is very simple to remember, they're big objects in space that are big enough to be rounded by self-gravity, but not so big that they catch fire and become stars. In our solar system, we're up around 29, and across the galaxy, we're up in the many thousands already. But we expect that we'll find up to 1,000 in our own solar system, and that we will find hundreds of billions in the galaxy. It's just incredible. Planets are everywhere.
Very last question of the night. I hope it's a good one.
You said that that's your favorite picture. What's your second favorite?
That is a good question. No one has ever asked me that. You mean of the New Horizons project? Yeah. Probably the team picture that we took the day of the flyby would be my second favorite picture. Thank you for asking. That's a really good question.
Thank you very much, everyone. Give a big hand to Dr. Stern. He will be available to talk more down here or out in the foyer. Thanks so much, everyone, for sharing tonight with us.
Thanks. That was great.